In this video, I want to just talk a little bit more about applications and do a few more examples. So one thing of applications are nutritional applications. So I just want to touch on these a little bit. So one thing as base starting ratios that you should know is that for carbohydrates have 4 carbohydrate calories for each gram. Fats have 9 calories for each 1 gram, and proteins have 4 calories for each 1 gram. So sometimes this could be helpful if you're trying to think about nutrition for an animal, right, or any patient really, and trying to maybe think about their diet and making sure they're getting all the nutrients that they require. So here's just one example to start. So let's say you have 400 carbohydrate calories. Well, how many grams would that actually equate to? So these are your base ratios. In this case, these are your knowns. So we start with our knowns. We're doing carbohydrates. So it's 4 calories for 1 gram, right? So these are our knowns. And then I know that the meal, let's say, has 400 carbohydrate calories, and I'm trying to figure out how many grams. Okay, so we're still using that same strategy of, proportions, just in a different way. So 1 times 400 equals 4x. 400 equals 4x, and we divide by 4, we get x equals 100. So 400 carbohydrate calories are in 100 grams of carbohydrates. And you can do similar examples with the fats and the proteins using 9:1 or 4:1 instead there. Another example using nutrition, it doesn't have to be necessarily related to carbs, fats, or proteins. It could just be some other nutrient that you would need. So let's say, for instance, we're looking at calcium. 1 glass of milk contains 280 milligrams of calcium, and we want to know how much calcium is in 1.5 glasses of milk, right? So we still start with our known. So we have 280 milligrams of calcium for 1 glass. I want to know how much calcium is in 1.5 glasses. So we're still going to go ahead and cross multiply here. I have 280 times 1.5, and then I have 1 times x. Now that 1.5, you can either change it to 3/2 and work with a fraction here, or I think we all know 1.5 is the same thing as 1.5. That one's pretty easy. So we can use our calculator. But either case, whether you're working with fractions or the decimal, it actually comes out to be an even 420. So there'll be 420 milligrams of calcium in 1.5 glasses of milk. And one more nutrition example here. So let's say, for instance, that 1 serving has 90 calories. We could ask something like, well, how many calories are in 4.5 servings? And again, we start with our known. So there are 90 calories in 1 serving. And we want to know how many calories are in 4.5 servings. So again, we're still using that same strategy. This is one of my favorite strategies. I really like it for just when you just have one unknown here, just one kind of missing piece. So here we're doing 90 times 4.5, and then 1 times x. Now, 90 times 4.5, again, you can either use the decimal or you can use the fraction form. It comes out nice. You get 405 here. So the answer then would be that there are 405 calories in 4.5 servings. Now, there could be some problems like this where maybe you just kind of know, oh, I could have just multiplied 90 by 4.5 and got the answer that way. And that's perfectly fine. So it's good to have more than one strategy. I do like the strategy, like I said, particularly when the examples get a little bit tougher, right? When it's kind of not as easy to determine of, are we supposed to be multiplying? Or are we supposed to be dividing? Then it takes the guesswork out. You have your two ratios, you cross multiply, and we can solve. Okay, so to wrap up here, I want to just look at some multi-step problems that we can do with proportions. So let's look at an example. So let's say a 7-pound cat needs, was it prednisolone at 2.2 milligrams per kilogram. And we want to know how many milligrams do you need? Now, this is a great one where, maybe pause the video here and try this on your own first. Think about what you need to do here. So the first thing I need to do is notice that my medication is given in kilograms, but my cat is given in pounds. So I do have to convert that pounds to kilograms first before I can even start to answer the question. Now, we already know this one. We know that 1 kilogram is 2.2 pounds. I know my cat is 7 pounds, and I can use X and a proportion to transfer this over. So I have 1 times 7 equals 2.2x. So 7 equals 2.2x, and I divide both sides. And I get that X is about 3.1818. So the cat is about 3.2 kilograms, rounding to the nearest decimal. So once I have that, now I can actually think about the question. How many milligrams do you need? Well, here, my known is that it's 2.2, it's a decimal there, milligrams for each 1 kilogram of body weight. Our cat is 3.2 kilograms. So now I can go ahead and use a second proportion to go ahead and solve this here. Okay, so I'm just going to go this way this time. So I have 1 times x is just 1x. And then I have 2.2 times 3.2. 1 times x is just x. I don't really need that 1 there. And then 2.2 times 3.2 is 7.04. So rounding to the nearest tens place, we get 7.0 milligrams. Now, because it's not exact and we are rounding, I do recommend putting the 0.0 in. It sort of lets the reader know that this wasn't exactly 7. If it was just 7, I probably just would have written 7. But if we're using consistency of using 1 decimal place, then I'm going to just put that in as 0.0. And then it makes it a little bit, I think, clearer for the reader that this was rounded. Now I can also take this another step. So let's use the same example. Let's say that prednisolone has a concentration of 5 milligrams per tablet. We could ask how many tablets does the patient need? So let's use the same example. So we know that the patient needs 7 milligrams. My tablets are in 5 milligrams per tablet. So I start with the known, right? I know that it's 5 milligrams for 1 tablet. And we know that we need 7 milligrams. And we would like to know, well, how many tablets would this be? So we cross multiply. I'm just going to go over here. We get 5 times x equals 1 times 7 is 7. And we divide both sides by 5. Now, when you divide by 5, you get 1.4. So the exact answer is 1.4 tablets would be correct. Now, of course, different medications can and cannot be cut, right? So that's something that is a different conversation here. And then also, how do you cut 0.4? So obviously, that's a conversation that you would want to have with the doctor, or in this case, the veterinarian, about, okay, should we prescribe 1.5 tablets then? Is that safe for the animal? Or does it need to be 1 tablet, for instance? So that part I'm not going to address here. That would be a question for the veterinarian. because 0.4 I think would be very difficult to probably cut. But my guess is you would probably round this to 1.5, again, assuming that it was still healthy for the animal to have that extra medication there. But this would be how we could figure out that dosage as well. So I like this example. I think it's a nice application where you're going through multiple stages, multiple proportions, but we can get to each stage and each part just doing one proportion at a time.